Hi guys, I welcome you to my channel. Today I'll be solving another question of try series or series that is in the Blind 75 called design, add and search word data structure. So what will be given that you'll be given two input. First is the array, like one input which have the operation we have to perform, like add of word operation, search operation, right? And another input will be the uh, another input where if we have to add something, we will be giving with the string. So we will perform respective operation, right? So I we have to write this thing, write the word dictionary, write this add word then search word. So in the last question we have already done the try question we have already done, where you see here one important thing, one new thing here. We will found that we will have dot in the character in the word. So dot denotes anything, like it does not mean that uh, we have to find dot especially. Dot can be anything. If this is b, it can be b, it can be d, it can be m, it can be p, right? It can be anything dot. Okay, so I have to make sure that whenever I find the dot, I skip that part and I will update the index. That is the name, that is the thing. Whenever we find the, so we will have a list, right? So not list, we have dictionary. So dictionary have B, then A, then D, then D A D, then M A D, then P A D, then B A D. Sorry, yeah, B this thing. So right, so we found out that if we had to find such that we find that such that if we find dot in initial or dot at any position, we will skip that position and we'll check other dot. So other dot, so there is chance that we have multiple word in that string. How I should explain you? So consider this case. Here we have a bad, so B will be the here and will go A and will go D, and B will be here, we go C and we have D, right? So my question, if you ask them, if I ask what is the what dot, can you find the string dot cd, right? Dot cd, right? Can you find it? So uh, here we see we have B C D, we have B A D. So we do not, if you take B A D, so if I take only uh, one subtree, if I take only one subtree, BC will never will found BCD never, right? We'll never found BCD. So we have to take all this subtree. So consider this A and C. You have this root and all children of root, that is A and C, and we have this root B, and so and B is dot, then we will skip this B and we have to check all possible child of the B, that is A and C. So I'll go A and C, A and D, A and A, B C D, B A D, A and D. I'll go A and D and try to find that if A and D is in the list or not. If like A and D is matching with the characters present in the search operation or not. A and D is not matching, right? A is not matching with C, right? It will return. If C is matching or not, C is matching, then I'll go further. D is matching or not. So basically, seeing that, right? Whenever we find dot, we have to check all possible subtree of that particular node. Correct? No, that's it. That is the thing point we have to search. So let me initialize first dictionary. Uh, Let me initialize the dictionary. Self dot root is equal to a dictionary that is default dist. Right, let me insert it. So we can do insert like this one. For char in word, and I have node that is pointing to self dot root. Uh, um, if not, if ch not in self node, right? If ch not in node, I'll create it node of ch is equal to new default list. Otherwise I will update my node. In both the case I will update my node. So node will be the node of ch, and I will append last character a hash. Node of hash is equal to true. We have reached the end of the character. Now next character, now we have to search it. So you see we have to do left and right? So better we go with the recursion. First I'll write that if there is no word, if no word or length of the word is 0, I'll just return true. We found it. Otherwise if there is no word I'll find, otherwise I'll go further and I'll try to do DFS. I'll write DFS here, def DFS. It will take two things. It will take index of the word and what mm, root, current root, right? So if index will be the, if index is the last, index is equal to, index greater than or equal to length of word, I'll return hash in the root. We are doing search, not search prefix search, right? So I'll do, if we have reached the current index, now check that if hash in the root, hash in the current node, if this is the present, then it will true, otherwise false. Now I'll go next and I'll try to check that if word of I जो है, word of I of index, basically word of index is equal to dot. If this is the case, dot, then what I'll do, I will loop the all possible subtree of the word of index. So for all possible subtree, that is for root subroot in current node dot values, right? I let me check that if current subroot is not a hash, because there is chance that there is chance that we have a and just a. So for a, it next will be hash, right? Now second a, we have a and b, and then we have hash. So it means that we have two value and we are trying to find b, a b, not only a, but a is hash here, right? So we can't go further to return. So we have to check that and here, and we are here, it means that we are not end of the word, right? It means that we do not have to take this, right, hash part. We have to take b part, correct? No, correct. Okay, so we'll take b part and I will write that check. I'll check here if subroot is subroot not equal to hash, only I will continue DFS part. So if DFS of index plus 1 and current subroot, if this is a true, if this is false, uh, if this is true, I will return true. otherwise I'll not do, I'll go and check for next if you find anything. So we are done with the if part. We'll do else part. Else we'll check that if ch not in not in current node, if ch not in current node, then return false. Otherwise return dfs of index plus 1, index plus 1 and index plus 1 and current node of ch. That's it. So I explained you one thing here, right? If a and we are trying to find this is dot, consider this is dot, we have hash here, right? So we have dot and we have hash here. So if subroot, now we have done this, we have done this for subroot in current node dot value, right? So basically what is saying, it is giving me, it is giving me this child of b, child of hash, right? Like a is the root, right? A is the root and let's see this example, a b and hash we have here, correct? No, we have this a b and hash. Now what I'll do here, we'll check that, try to search if length is equal to what of 0, sorry, index of index, what is index here, index is 0 currently, 0 is not, then we'll move further, we move here and we'll check that what we have to search, 0 0 b, you have to search 0 b, okay? So 0 of index is equal to dot, 0 of dot, yeah, it is dot. It will check that if subroot in the current root dot values, so what is the current root, current node, this, and what is the value of this, uh, value of this is this b and hash. Subroot, basically subroot is this, okay? Subroot is this, okay, b and hash. So it will go to b and go to hash. So if that is hash, if that is hash, so I'll check like this only, I'll check like this, if subroot not equal to true, it means that we are, if subroot not equal to true, it means that we are end of the root, or we are end of the root. So we have subroot here a and we have hash, we have b, right? We have hash, we have b. So we have hash and we have b. So basically hash is also hash is inside object, right? Hash is inside object. So if there is only a, we will check that, we will, if there is only a in the search bar, so it will return here from here, because we find the hash and will return, right? We find the hash and the root we are trying to get, it is hash instead. I am not able to, let me explain again if you are not able to understand. So we are we have root something like this, a b, okay, and this is hash, okay, and this is also one more hash we have here, okay. And now we have to find a only, just a we have to find, right? Or dot b we have to find, dot b. So what of index is a, right? What of index is dot, yeah, this is index is dot. So I loop all the value of subroot, all the value of subroot. So this is the root, right? So all the subroot, what is the subroot? This is the root. This a is pointing to somewhere else. This is the root. 0 is the root for the now, and a is the subroot for them. Okay, so only one item we have a. Okay, so we will take a because there's something, there is empty, there's nothing we have to take, so we'll take a, and I'll go further because there is only one item left. See now, subroot is not true. Subroot is not true, so we'll take that dot, and I will update my index. So this is update my index plus one, and subroot is already updated. That is a is going to the this new root. Okay, now a is going to new root, and so index basically becomes the what? Index becomes 2. Initially it was 1, 0, now index become 1, and what is length of this index? It is 2, right? So we'll not take a, we'll move forward, and now I'll try to check that if index is dot, what of index is dot? No, what index is b, we have taken already a, so it is b. So it will, if subroot of true, subroot not equal to true, yeah, it is not. So what of index is not equal to dot, yeah, it is true, it is b. I'll try to check that if ch not in current node, ch in the current node, basically v is in the current node, I will update my index plus 1, and I'll update my current index as well. So this is current index pointing to hash, and we are written true. uh, if I just want to find a, right, we have the a, now we go next first, and we try to find dot. Now consider this thing, we only have dot, nothing else, or just dot and b, a and dot, we have a and dot. Okay, so for the first time I got the a, I'll call this, I'll update the index, and I will call this root b and hash. Now we have a doubt because this is dot and we don't know we have which one we have to take, right? No, so we will do values. These are the values of a, b and hash. Okay, now b and hash, subroot is not equal to 2, so b is not equal to true, yeah. As I'll call index plus 1, and subroot is hash, subroot is basically b, and index is basically 0 1, and it is not greater than or equal to length. I will update my next. Index is what? 0 1, and I will have, we have already 0, now we have 1. When 1 is pointing to b, 1 is pointing to b, uh, when 1 is pointing to b. Okay, this is hash, b is hash, so subroot is not true. This is not end of the root. We have something, so we'll take it and we'll mark that we found the element. We'll update the index, that is index become 2 0 1 2, and I'll give this subroot to this element b. So b here, we have b here. Okay, so what we'll check that if index is equal to, index greater than equal to what of length, yeah, index is 2 now, 2 is the length of the string, so 2, yeah, it is correct. Now I'll check that if hash in the subroot, so hash in the b, yeah, it is hash is inside b, correct? No, yeah, so it will return true, and if this is true I will return true will work. So consider the case uh, where we have a and then hash, and bc is not available here, just a, or we can have a b hash, a b and dot. Consider this case, a b and dot. So sorry, I have written this much. Consider the case we have a and b and dot. Okay, let me write here a b and dot. we have a and first string a, the second character b, and the third string is dot. Now what happened that we have a, we found a, will update my string index to 0 to 1 and current nodes to b. Now we have this current nodes to current node basically current root is the root of ch, that is a. Now we have a here, we already have a here, right? We have a here, this is the one more root, it is pointing to 0, 0 of a. So a is then 0, right? It is in 0, so we will update my index plus 1, that is 0 to 1. We have 1, we found one element, and ch is equal to ch of node, that is now we have this children. And now we have, now let's check that b is not equal to dot, yeah, it is not equal to dot, so we have dot here. So we have, so we'll go to the else part and we'll try to check that if ch in the, not in the current node but b in the current node. But so what I'll do, I'll update my index, I'll update my current index, so that is hash, current index is hash. Okay, here is the catch. Now and what is the third index here? Dot. So we have not reached yet, that is second index, we have not reached yet the this if condition. Now I'll check that if word of index, word of 2 is dot, yeah, it is dot. So now I'll check all the subroot. The subroot basically subroot of the current value, so all the subroot of b, that is only hash we have, right? Hash is pointing to true, hash is the object which is pointing, hash is not an object, hash is a variable which contains two boolean value, but it is inside an object. And I had to take all the value of hash, all the value of b, like all the value of child node. So only we have hash here, so true, it will take true as a subroot. Like consider the case, we have c here, like, right, we have hash, so all the value of hash will take as a true. So subroot is true, so I'm not going to do again if subroot is true, then do this thing, do that thing. I'll just write that if subroot is not true, then I'll check it, otherwise I will just move forward and I will return false from here. I know it's taking time to explain you, but what it is worth understanding. So I'll just return the dfs of 0 and current node is self dot root. We can add this as well, if subroot is equal to true, I'll just return false. We are here, but I cannot like that also, it should work. Let me submit it. Yeah, ch is not defined, so I have to take word of index, and this is also word of index ch. Yeah, it is working fine, let me submit it. Yeah, it worked, and we have beat the 94% of Python developer. So yeah, it's very easy to understand question. What we had a catch here, that when we have b dot dot or b dot, so there were the edge cases, and we have covered this edge cases using this if subroot is not equal to true, then only check that. To catch the edge cases, we have to write this, otherwise I tried it multiple time and failed, and I just tried this code and it worked. So yeah, so thanks for watching, we'll meet tomorrow. And thanks for 72 subscribers. I'll really appreciate that you have subscribed me. If you find any value or you want to see how I'm doing growth in my career, uh, uh, that's why you have subscribed me. And thanks for watching, and thanks for subscribing me, and I hope more people subscribe this channel so that I can work really hard to make better content from this one. Okay, thanks for watching, bye bye.